video we will learn about kruskals algorithm. And we use the packages. We import all the usable packages, like we use the scanner and eraser to take the usage of erase and reading from the prompting from the user. So we create an edge class. That is comparable to implements comparable to compare edges by weight. So source vertex, destination vertex, and weight of the edges. So source vertex, destination vertex, and weight of the edge. So constructor to the initialize the edge, constructor to initialize the edge, So we create an enter to we create a constructor to source, destination, and the weight. Source, destination, and the weight to override the method to compare the compare method based on the edges and weight. To override the method, we sort the edges in we sort the edges ascending order of weight. So we sort the edges in ascending order of the weight. So we create a graph to represent the graph. We create a graph to represent the graph and perform a kruskals algorithm. We initialize the number of vertices and edges and array to stores all the edges. So we create and we again create a constructor and we again create a constructor to initialize the graph with vertices and edges. Initialize the number of vertices, initialize the number of edges. Initialize edge with area and size. Initialize edge with area and size. Function to find the subset of a parent array used in an algorithm. If I it is parent, if find the subset of an element, if I equals to if I is its own parent, return I. Recursively find the parent. Okay, now we'll find the union of two subsets. We'll find the union of two subsets while we're finding the subset of x and finding the subset of y, and union of two sets. So function to perform kruskals algorithm to find the MST goes on like array to we create an array to store the resultant MST. Create an array to store the resultant MST. And we create a store to result MST and sort the edges by weight and sort the edges in ascending order of weight. Array to store the parent of each vertex, and we create an array to store the parent of each vertex. Initialize all the vertices, initialize all the parent, initialize all the vertices from their own parent. We create an index for result and we create an index for sorted edges. So we will run a loop included v minus 1 edges in the result. So we will run a loop including v minus 1 edges in the included v minus in the result. So we pick the smallest edge. From the sorted edge list. So we will find the subsets and we will find the subsets or parents of the source and distance of the edge. So if x and y belongs to different sets including this edge won't cause a cycle, so they need to be in a single set. So including this edge of the result, including it in the result, union of two word sets. Print the resulting MST. System dot print the resulting MST. System dot out dot edges in the minimum spanning tree. We'll print the print the resulting MST. And now we'll coming to the main class. So we create a scanner object to take prompt from the user and enter the number of vertices, number of edges, and we'll create a graph with vertices E and E edges G. So we prompt the user to enter the edges in the format of source, destination, weight format, and we take the input and we take the input source and we take the input destination, we take the input weight. Graph of edges equals to, and add the edge to the graph, and we call the function kruskals MST, and we'll close the scanner. When we run this code, we need to enter the number of vertices 4 and the number of edges 5. We'll take that, and we enter each edge from the format source, destination, weight format, and if we press enter, we will get the minimum edges in the spanning tree with completing the code execution.